let's continue to practice breaking up velocity vectors into their components. Here we go. A soccer player kicks a ball with an initial velocity of 20 meters per second at an angle of 60 degrees. Calculate the ball's horizontal and vertical velocity components when it's kicked. Okay, so here's our soccer ball. It's being kicked at 60 degrees. The problem did not say, but I'm gonna assume that that is from the horizontal. And the value of that initial velocity is 20 meters per second. So I'm being asked to break this up into its horizontal and vertical components. So what it wants is, it wants to know from this vector, how much of it is going upwards, that would be VIY, and how much of it is going over, that would be VIX. Okay? So what I need to do is I need to create a triangle to help me see how these components would be related to the 60 degrees. So the triangle that I could create would look like this. I'm going to have my original 20 meters per second velocity, and then I'm going to keep VIX on the bottom, but I'm just going to move the VIY over to here. So specifically, I'm sort of imagining that I could take this vector here and move it over to there, right? That's the triangle I'm creating. So here is now VIY, and this angle is 60 degrees. Okay, VIX, I can see, is going to be the adjacent to my 60 degrees. VIY is going to be the opposite to my 60 degrees. And 20 meters per second is going to be the hypotenuse. So let's start first with the horizontal. So I can tell just by looking at the picture that the cosine of 60 degrees is going to be equal to the adjacent over the hypotenuse, which is VIX divided by 20 meters per second. Okay, that means that VIX is going to be equal to 20 meters per second times cosine of 60. And so VIX is going to be 10 meters per second. By the way, make sure that your calculator is in degrees. If it's in radians, you're not going to get the right answer. And then if I want to find out the VIY, I can use sine of 60 because the sine is the opposite over the hypotenuse. The opposite being VIY, the hypotenuse being 20 meters per second. Multiplying both sides by 20 tells me that VIY would be 20 meters per second times the sine of 60 degrees. Again, make sure your calculator is in degree mode, 17.3 meters per second. Okay, so this is 10 meters per second. This is 17.3 meters per second. And then I could then use those components, VIX and VIY, to figure out how high the soccer ball is going to go at its maximum point and how far over in the horizontal direction the soccer ball would land and hit the ground. That would be the soccer ball's range. And let's try one more. Example 2, during a field goal kick, a football returns to the ground with a horizontal velocity of 15 meters per second and a vertical velocity of negative 22 meters per second. Determine the ball's resultant velocity. That's the combination of the initial and of the horizontal and the vertical components at the moment it strikes the ground. Okay, so now instead of thinking of initial velocities, this is the final velocity. So the football has been kicked up and it's actually returning back to the ground here, and this is the moment that we're considering, okay? So at this moment, the football has this velocity here, which I'm going to call V final, and it has components. It has a horizontal component, V final X, and it has a vertical component, v final y. We're told that the final component is 15 meters per second in the horizontal, and it is negative 22 meters per second in the vertical. And it might be helpful for me to label that the other way. Okay. So now the question is actually, what is this, right? What's the value of like the combined velocity, the resultant velocity of the two of those? So I'm going to make a triangle. I'm going to imagine that I can cut and paste one of these vectors. And so I'm going to move this one over in my mind to here, right, and make a new triangle. So my triangle now is going to look like this. Going to have v final here. So the horizontal component is here, the vertical component is here, and the resultant component is here. Okay, this is 15. This is 22. I'm not going to call it negative anymore because my picture shows that it's down, and my triangle is already accounting for the positives and the negatives. So since I'm drawing the directions themselves, I don't need to use positive and negative anymore. I can drop those designations. Okay, and so I need to find not only this, right, but I also want to find this angle. Okay, so here we go. First of all, how can I find the resultant vector, the VF? Well, I can use the Pythagorean theorem, right? The hypotenuse squared is going to be equal to the sum of the squares of the two legs. So VFX squared plus VFY squared. This is the Pythagorean theorem. So this means 15 meters per second squared plus 22 meters per second squared, right? And I could take the square root of that whole thing. So I'm going to get 26.6 meters per second. And then what is the angle? Well, I've got this side, which is the opposite side. This is the opposite side, right? Compared to this angle. Compared to that angle. And then this horizontal component would be considered the adjacent side. So if I want to get the angle itself, I would just compare opposite and adjacent, and that is tangent. The tangent of this angle is VFY over VFX, opposite over adjacent. So that's 22 meters per second divided by 15 meters per second. Okay, how do I get theta all by itself? I take the inverse tangent. So theta is the inverse tangent of 22 over 15, which is 55.7 degrees.